Okay, so this is just extra. So this isn't a part of the notes that you have. This is just me throwing in a few extra examples for transformations and kind of working it two directions. So I'm going to actually start with the verbal description and then we'll graph it for a couple of examples. So the first one, suppose we start with the function y equals the square root of x. All right, then I want a new function with, so I want a new function with the original reflected about the y-axis shifted down 3 units and vertically stretched by 4 units. Alright, so there's 3 transformations to get my new function. I want it to flip over the y-axis. I want it to shift down 3 units, and I want it to be stretched vertically by 4 units. So there's 3 transformations. So there's 3 things I have to do to get to my new function. So I'm going to call my new function g of x. Alright, so the first thing, when I want it reflected about the y-axis, well, that's when I put a negative on the x value, right? My x values become negative. It reflects over the x-axis. And so square root of negative x first. So that's the reflected about the y-axis. All right, so that's 1. All right, then 2, I'm actually going to do the stretch next, kind of follow my order of operations. I have to take care of reflection stretch. The last thing you always take care of is vertical shifts. And so I'll do my vertical shift last. Well, I want it to be stretched vertically by 4 units. That means all of my y values would be multiplied by 4. And so it's taking the function and multiplying it by 4. And so I get the 4 outside of the function square root of negative x. And that would be a stretched vertically by 4 units. Every single y value gets multiplied by 4. And then the last thing is I'm going to get it shifted. Oops. I'll write the words over here. Shifted up by, shifted down by 3 units. So it means I want to subtract 3 on the outside of my function. So 4 times the square root of negative x outside of the square root minus 3. So the square root part's only on the negative x. And then separate, we subtract by 3. And so that will be shifted down 3 units. All right, then the graph of that. All right, so graphing it out, my original function was the square root of x. The 3 key points that I use on the square root of x are those 3 key points. So 4, 2, 1, 1, and 0, 0. All right, so the first one is I'm going to reflect it about the y-axis. And so it's going to be reflected about, and I'm just going to draw that one in red. So that means it's going to come over here of the exact same shape. So 0, 0 is still a function. But then it's going to be at 1, negative 1, 1, and negative 4, 2. All right, all of my x values become negative. So there's the first shift. Alright, then the second shift is it's going to be stretched by a factor 4. So that means all of the y values get multiplied by 4. And so I'm going to draw that over here. And so my second shift, all of the y values get multiplied by 4. So 0, 0 still stays, all right, because 0 multiplied by 0 is still 0. But negative 1, 1 changes, right? I multiply that 1 by 4, so that's still at negative 1, but now it's going to go up here at 4. All right, so now it's at negative 1, 4, right? It's been pulled up by 4 units. I don't know if I gave myself enough room to do the next stretch. It will be up at 8, right? Because I multiply, so my negative 4 is still negative 4, but then I've got to multiply 2, and so it's going to be up at 8. So I need to move this up. So 1, 2, 3, 4, 5, 6, 7, 8. So now it's up here at negative 4, 8. And so it's been stretched. It's still a curve. All right, but it's been pulled up by 4 units, vertically stretched. And then the last thing is to shift it down. And again, I'm just going to shift it down on this graph here. I'm going to probably do my shift down in red just because it's easy to see. And so all of these get shifted down by 3 units. So 1, 2, 3. So now 0, 0 is at 0, negative 3. This gets shifted down by 3 units. And so it's now at negative 1, 1, negative 1, 1. And then this gets shifted down by 3. And so it's now at negative 4, 5. And there's the final graph, if I can get it up there. There's my 4 square root of negative x minus 3, where I've taken the original square root of x function, reflected it about the y-axis, stretched it by 4 units, and shifted it down by 3. All right, the next one I'm not going to graph, I just want to know what the new function is. So kind of the same idea, as I just want to find the equation that shifts the graph of f of x to the right 2 units and up by 3 units. All right, so I'm shifting to the right 2 units and up, you can read that, up by 3 units. So I'm doing a horizontal shift by 2 and a vertical shift by 3. All right, my original function, so f of x, the one I'm doing my and again, I'm not going to graph the shift. I'm just going to write out how we change it. All right, so my original function was x squared plus 2x minus 3. All right, that was the original. This is the function I want to shift to the right 2 units and shift up by 3. So we'll take care of the right. So first thing I want to do is I want to shift to the right. So that's a horizontal shift, which means it has to do with the x values. 2 units by 2. So I want to go in the positive direction by 2, but when I change it horizontally, what I'm actually going to do is I'm going to subtract 2 from all of the x values when I plug it in. And so when I write this shift in, my new function is going to be f of x minus 2. Right? That's the shift. That means I'm shifting to the right 2 units. And then when you plug it in, you're changing all of the x values. All of the x values get changed by that. And so the x, instead of x squared, it's going to be x minus 2 squared. Instead of 2 times x, it's going to be 2 times the group x minus 2. And so my new function, when I want to be shifted to the right 2 units, is going to be x minus 2 squared plus 2 times x minus 2 minus 3. All right, and there's the new function where I've shifted to the right by 2. All right, second shift was I want to shift up, which means vertically, by 3. It means I'm going to add 3 to my function. And so so I'm looking here. This is the function I now have. So f of x minus 2, and I want to add 3. When I add 3 and I want to do a vertical change, it's to the entire function. So it's outside the function where I add 3, and so I'm just going to add 3 to the end of this. So y equals x minus 2 squared plus 2 times x minus 2 minus 3, and then there's another plus 3. And so what happens actually, if I want to simplify it, those 3's reduce or cancel. X minus 2 squared plus 2 times x minus 2 would be the new function where I shifted my original function f of x. So this would be the original. If you graphed this and then you graphed this would be maybe g of x, if I wanted to call it by a different name. it would be that original function where I've shifted to the right 2 units and up 3 units, meaning all x values of the original you would add to, all y values of the original you would add 3. Right, every single point on the original graph of the function, all of the x values have 2 added to them, and all of the y values have 3 added to them. And like I said, I'm not going to actually graph it, but that is what would happen graphically. I'm going to do one more. And again, I'm going to just, what are the different transformations? All right, so what are the transformations? All right, so the original function is the square root of x, and then what have we done to it? What are the transformations on it? And that's all I want to know. You could graph it and do it, but you would do, there's 3 transformations. You'd start inside, so inside on the x term I'm multiplying by 5, and so what that means is that's a horizontal compression by 5, which actually means by 1/5. All of the x values get divided by 5. So it's smushed down towards, again, so it's smushed down towards the y-axis. It's compressed towards the y-axis. Right, horizontal compression. Then there's the negative out front, so that's a reflection. So again, 1, horizontal compression by 1/5. 2, there's a reflection about the x-axis. Right, all the y values get made negative, so again, it's about the x-axis. And then the last one is the shift up by 4. Alright, so those were the 3 things you do. You would take all of the x values divided by 5. That would be one thing you do. You would reflect about the y-axis, which means all y values become negative. And then you would add 4 to all y values. Again, I'm not going to graph it, but those would be the transformations that you would do. Alright, so like I said, that was just a few extra kind of examples, just reminding you of what the different reflections, transformations are, how it affects the graphs in those cases. Alright, so that was just a few extra examples. Best thing to do is go and practice it.